Hello and welcome. In this video, I'm going to do the exact same project as before, which used the UART, but this time I'll be using the microcontroller's USB port to emulate an RS-232 serial port. Here on the workbench, you can see which terminals are used in the USB communication. This configuration is almost the same as the previous one for the same project. However, since the UART peripheral is not being used, I have removed the use of that peripheral. The first thing I enabled was the USB-FS in device mode, which allows reserving the pins related to that peripheral. At the firmware level, I have selected the device class called CDC, which allows emulation of a COM serial port, and I have left the settings at their default values. I have kept timer 5, but I don't think I'm going to use it. Also, I keep the Watchdog feature, that's important always. Regarding the device's clock, the USB peripheral needs an exact 48 MHz. It can be sourced from the internal oscillator, but I decided to derive it from the external crystal. With the correct multiplication and division values, I get the right frequency. This is the code generated by the workbench. This function here is the one that sets up everything related to the USB port. And another line that was generated is this one, which indicates a supposed task related to USB, and I will analyze it later. What I added here in the main function is the activation of the watchdog, and in the main loop, I calibrate the watchdog value to prevent a CPU reset due to its overflow. Now, if I go to the task created related to managing USB communication, you can see that this example reads any data frames sent from the host and forwards it. It's something similar to the example I did with UART. This section is where I should add any of my code, but the processing must be done before transmitting. I added code from line 127 to 135. And it's basically what was done in the previous project, that is, if the byte above is 7, a logical high is set on the LED terminal to turn it off. If it's 3, a logical low is used to turn on the LED, and I increment the first byte of the reception array by 1. It can be seen that the transmission process is synchronous or blocking, as it remains in a loop for a certain period, waiting in case the transmission process is not completed. I was considering creating my own task based on state machines and asynchronous delays, but my goal is only to demonstrate the functionality of the USB module. Here is the development board. Before downloading the project to the microcontroller, I need to check which COM ports are available on my PC. The only available one is COM4, which corresponds to the programmer and debugger of the development board. So, to download the project, I go to its properties, select the debug as option, and click on debug configuration. In the new window, under at link debugging, I create a new configuration, and finally, I press the button labeled debug. A window appears, informing me that I need to save changes to the main file, so I click OK to perform that action and continue debugging. The project is recompiled, and the software tries to communicate with the debugger and programmer. When it succeeds, the debugging stops at the first line of the main function. I press the button for the code to continue executing. Then, I go to the development board to connect the USB cable to the corresponding port, which is near the bottom right corner. Then I open the device manager to determine the COM number assigned to the hardware, and it's number 9. Also, Windows notifies me that it has detected the hardware and is configuring the device. Using the Hercules software, I open COM port 9 and proceed to send the number 1. It can be verified that it returns the number 2. I send 3, it returns 4, and the green LED diode turns on. Now I send 4, and it returns 5. I send 7, it returns 8, and the LED diode turns off. And once again, I send 3 to turn on the LED diode. I can confirm that the project worked as expected. Thanks for watching the video.